these 5?
Yes. Okay, so a question on the common names on page 4. It will make your life a lot easier if you know these.
So you can almost make like a little addition, like separate flashcards.
Yeah, you can make additional flashcards. So these common names, the ferrous, ferric, through plumbus, plumbic, you do need to know those. It will make your life easier.
So ferrous is always Fe plus 2. It's
yes.
Never going to be a different. Okay.
Mm-hmm. And so yeah, knowing those will make your life a lot easier. We're going to kind of put this together now, because I've shown you how to write the formulas for compounds, and now I'm going to show you how to name them. So we'll get into that fun stuff. So I know I like it, but I might be a little biased. But I liked chemistry because it was hard. I know it's hard to believe, but it didn't come easy to me. I definitely had to work at it. So now it's easy because I've been doing it so long, but you would get to this point too, I know. Okay, so naming ions. Cations. When you name cations, the way you name them, metal group ions, groups 1, 2, and 3, these are your main group ions. Metal ions are named by listing the metal followed by the ion. Okay, so potassium forms a +1 ion. The way you would name it, potassium. So if I just said potassium, that does not tell me that it has a charge. It's got to be potassium ion. So on a quiz or a test, if I had this and said name it, and you just put potassium, you would lose credit. Okay, so it seems really nitpicky, but there is a difference. Potassium versus potassium ion. So potassium doesn't have a charge. Potassium ion has a charge. All right, what charge does magnesium form? +2. So that you would name that magnesium ion. Aluminum, Al +3, aluminum ion. What's that? Yeah, we don't capitalize, so the aluminum ion. Now, transition metals we've touched on briefly already. The common way of naming it, which we talked about, the ferrous, ferric, cuprous, cupric, aurum, aura, or aurus, auric. The lower charge has the us ending. The higher charge has the ic ending.
Is that only for the ones that have the Greek or Latin name too?
I'll give you an example. So the ones that I gave you on page 4, I gave these to you because they have the Greek or Latin roots. It's not ironous or ironic. It's ferrous or ferric. The rest of the ones that have the us and the ic are based on the name. Like we'll see chromium, it will be chromus, chromic. So I just gave you the funky ones. The rest you'll just add to whatever the name is. So, so there's the common way to name transition metals, the us and the ic, and then there's the IUPAC way. The IUPAC way is a lot of students' preferred way because it's a lot easier. So this chromium 2+, the IUPAC name would be chromium, and then you just put the charge in Roman numerals. So it would be chromium 2 ion. For chromium 3, it would be chromium 3 ion. So the common would be chromus ion. And this one would be chromic ion.
And that goes for not just the group in between the metals and the non-metals and alloys here, but also this bottom guy too that's still intertransition.
Right, so your transition metals, remember, they go from here all the way to gallium, all the way to tin, all the way to bismuth. And then you have your intertransition metals. We don't see a lot of intertransition metals, forming ionic compounds in this course. It's not that they don't exist, but, there are a few, but that we'll come across. But so I want to make it very clear that the main group metals, groups 1, 2, and 3, you do not have to put Roman numerals. You do not. It doesn't have to be potassium 1 ion. It doesn't have to be magnesium 1 or 2 ion, aluminum 3 ion, because they always form the same charge. You see what I'm saying? Like all of these are going to be group 1 or group 1 will all have +1. Group 2 will all have +2. It's these transition metals that can change. They could be a +2, they could be +4, and so you need to state that clearly. So we've learned how to name the cations. Remember that the cations are formed by metals. Metals lose electrons to form cations. And I'll say this again. And it never hurts to say this too much. So metals lose electrons to form cations. Non-metals gain electrons to form anions. So now we're going to learn how to name anions. So what charge does bromine form when it makes an anion? -1. So the way you name that ion, it's not bromine ion. You replace the ending of the element with "ide," followed by the word ion. So this is bromide ion. So some of you were picking up on that earlier when I would say, sodium ion, chloride ion. Oxygen is, when it forms an ion, it's -2. So that's not going to be oxygen ion, it's going to be oxide ion. Sulfur forms the -2 as well. That's not going to be sulfur ion, it's going to be sulfide ion. Nitrogen, -3. It's not going to be nitrogen ion, it's going to be nitride ion. Now with anions, on a quiz or an exam, if you say nitride, but you leave off ion, it's still, you get some deduction. Not full. If it's worth 1 point, you probably get half a point off. But you need to put ion. Okay, phosphorus forms a -3 phosphide ion. maybe at the bottom of this next page, you can write this. I'm going to give you a few that are easily confused, these anions, since we just went over how to name anions. S minus 2 versus SO4 minus 2, SO4, or SO3 minus 2. This is sulfide ion, commonly confused with your polyatomic ion, sulfate ion. Also confused with sulfite ion. Okay, nitride ion is commonly confused with nitrate ion in nitrite ion. So you remember I was talking about making little quizzes for yourself? You can list these ions and ask yourself to name them and, make sure you're very specific.
When you have like SO4 2 minus and SO3 2 minus, is it the one that's lower always going to be 8 and the one that's lower is going to be 8?
Yes, as a rule.
Okay.
So it, a lot of times students want to say, well, if you have 4 oxygens, it's always going to be 8, or if you have 3 oxygens, it's always going to be 5. But you can't do that. It's just going to be the higher of the 2
Okay.
within that. Other commonly confused ones, Pu minus 3 versus PO4 minus 3. So phosphide ion versus phosphate ion. I think I covered all the big ones that get confused. Okay, so we've learned how to name anions, cations, and anions. Now we're going to learn how to name ionic compounds. So ionic compounds, it's not that much of a step to name ionic compounds now that you've learned how to name cations and anions. So ionic compounds are named by listing the cation first. So cation name. And if you're dealing with Roman numerals or dealing with transition metals, don't forget the Roman numerals. Or you can use the common, the us, and the ik. And then you follow it by the anion name. Big thing with naming ionic compounds. The word ion never appears in the name of ionic compounds. So what happens a lot of times is after I've taught students how to name the cations and the anions, and they've heard me talk about, well, I'm going to take off points if you don't have the ion, so then when they get to ionic compounds, it's like ion, 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 all over. So I'll show you this one. Magnesium ion, and this is not correct, so you don't have to pick magnesium ion carbonate ion. That's incorrect. All you have to do is say magnesium carbonate. That's it. So ion does not appear in the name. And remember, magnesium is an alkaline earth metal. It's +2. It's a main group. You don't have to say magnesium 2 carbonate. It's just magnesium carbonate. And this, go ahead.
Sorry. When you said groups 1, 2, and 3, do you also mean the negative side of it too? No, the negative ones are the ones that we
Second. So, all right, so how would you name this compound? So that's your polyatomic ion NH4. That's ammonium. So it's just going to be ammonium and then not sulfur, but sulfide. Excellent. Ammonium sulfide. Okay, so if you see a metal, so your metals are going to be listed first. It's a transition metal. This is when that alarm should go off in your head. Ding, 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 ding. I need to have Roman numerals, or I need to use the us and the ick. Now, if I had this on a quiz as a question, you could put a Roman numeral, or you could do common. I have some students who love to do common. Any opportunity to get, they will do the us and the ick. I have other students who will avoid it like the plague. And they will only acknowledge common when I give them a name that's common. Oh, I have to remember that. Oh, I don't like that. So if you're kind of resistant with the common, the us and the ick, be aware that on a quiz or an exam, there will definitely be one where you have to use common. So, you know, if you think, oh, I can just do Roman numerals and I'm fine, you will miss some points. So, okay, so let's name this both ways. We'll name it the IUPAC way first. So copper. Now, you look on your periodic table for copper, and you'll see two and one. Well, which one could it be? This is where you do the cross and raise. It's going to be 1. So there is no subscript here. So if there's no subscript, it's implied that it's a 1. So you're going to be raising this, you're going to be raising this 1. You'll be raising this 2. So it's copper plus 1. So then for IUPAC, it's going to be copper 1. And then it's not sulfur, it's sulfide. Yes?
Isn't copper, not copper, sulfur, 2 minus that?
Mm-hmm. But so you're bringing up the 2 minus. So that works out.
Okay.
Okay, now, would it be cuprous or cupric? Cuprous. Very good. So cuprous, sulfide. Okay, so we have a metal. Is it a group 1, 2, or 3? No, it's a transition metal. So this is when, ding, 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 I'm going to have to put a Roman numeral or an us on it. So in order to figure out whether it's an us or an ick, do the cross and raise. So you're going to have Fe plus 2, acetate minus 1. So it's iron 2 acetate. So ferrous or ferric? Ferrous, yes. Ferrous acetate. Questions on any of those that I've worked for you? All right, I want you to work through the next 4. How's it going?
Easy when you're able to flip and look at it, but I can definitely see how you need to memorize those ions.
Yes, it is easy when you're able to look at the polyatomic ions and say, oh, no, I know that's bicarbonate. I would have gotten it. You will not be given these on the exam or on quizzes, so you have to know these. So otherwise, you can see how I wouldn't know this one, I wouldn't know this one, I might be able to get these two. So definitely an important thing to know for Unit 2. So memorize those polyatomic ions. How do you name this compound?
Stannous phosphide.
Stannous phosphide. Or, what's the other way? 10 2 phosphide. Good. And then copper 2. Good. Bicarbonate. And then I don't have a preference. Cupric bicarbonate. So I don't have a preference either way, whether you say IUPAC or common. Just be
I was
aware.
talking about like the bicarbonate or the
Hydrogen carbonate.
Yeah. Which one will we see?
You will see bicarbonate. I think hydrogen.
Sounds weird with hydrogen
Yeah.
Yeah, copper.
Cooper hydrogen
Copper 2 hydrogen carbonate. It gets confusing. You really will see bicarbonate. So I thought you were asking about IUPAC or common.
Will you ever, on a question on an exam, ask for one over the other?
Will I ever ask for one over the other? It's possible. So I could say, name this compound using common nomenclature. But by and large, when I'm asking, I'll say either IUPAC or common. But I most definitely will ask you to write the formula from a common name, if that makes sense.
Oh, so if you give us
So if I said
the words.
cupric bicarbonate, you're like, oh, I did not memorize that. I don't know what it means. I would know it if it was copper 2.
Oh, so if we're going the other way.
Right.
Yes, then okay.
Mhm.
Got it.
Okay, Fe2O3. How would you name that?
Ferric oxide.
Ferric oxide or iron 3 oxide. And this last one is all polyatomic ions. Ammonium dichromate. Very good.
And if I remember, I took one many years back, this builds kind of the base for when we get into that, right?
Yes. Yeah, you
So
do see a
really have to know those.
You see polyatomic ions. So if you remember, I was talking about how units 1, 2, and 5 are similar, and units 3, 4, and 6 are similar. Unit 5, I always tell students, review your polyatomic ions because we go over them again and again.
Will
Yes.
we have to memorize the diatomic atoms too?
Yes.
Okay.
I'll give you a easy way to remember that too.
Okay.
Yes.
Is there any way, like, if you don't, like, if you were just, like, on the test, remember, like, an 8 or an 8?
It just depends on the particular polyatomic ion. Like nitrate is NO3 minus,
Yeah.
sulfate is SO4
Yeah.
minus 2. So it's just, polyatomic ions are hard. And so you're going to spend a lot of time memorizing polyatomic ions. So yeah, just kind of get that in your head. Okay.
Do you, sorry.
No, you're fine.
On these, I mean, I'm good at memorizing stuff, but at the same rate, when it starts throwing numbers in like this with charges, that's a nightmare. So, do you know of any like study resources out there, or like YouTube videos or anything where
You can
there's a way
check.
to break that down to where you can remember the numbers or?
I had students make up songs about polyatomic ions. I don't remember the songs, and I should have recorded it, but that's how she memorized her polyatomic ions. But yeah, you're gonna have to, if you know you have trouble memorizing these types of things, then start working on it now. And for me, the only way I did it was just over and over rewriting. You know, so you wake up in the morning, you have your breakfast, you're eating your breakfast, and you're writing your polyatomic ions out. You know, you have lunch, you do the same thing. You just keep plugging away at it. But yeah. Oh, you're welcome. On page 8, I have named the ionic compounds from page 4. Remember, page 4. Where's the wrong page reference? Page 5, yeah. I was going to say it's not. Page, so it should be page 5. Thank you. This is the page where you did all of that crossing and dropping. Now you're going to name those. So that's what I was talking about, those numbers refer to. So practice this on your own. Practice naming these. I will have the answers to these the next time we meet. And I'm going to move on to, so you get an idea. So on pages 10 and 11, you'll get an idea of what you're going to be expected to do on a quiz or an exam. So you could be asked to name ionic compounds. So that's what we just went over. And there are going to be some that are very straightforward. Like number 2, here, do you see any transition metals? No transition metals, so it's just going to be potassium chloride. So I want you to take a few minutes to, try and name as many of these as you can, and then I'll go over these. I know a lot of you are working hard on this, and I'm going to go over all these answers now. This will give you a good foundation. I want you to be working on experiment 8. That is due the next time we meet. Experiment 8 is all neuromanufacturing.
So the whole experiment, not just the pre-lab?
There is no pre-lab for experiment 8. Experiment 8 is a lab that can be worked entirely outside of lab, and it's all nomenclature practice. So you can do the first 3 pages. When you get to the 4th page, you might have trouble because the Lewis dot structures, we haven't gone over that. So don't do the 4th page, but do the first 3 pages. Okay, so the first one is calcium carbonate. Number 3, this is where knowing your polyatomic ions is going to pay off tremendously. You know sulfate's -2, so iron must be +2. So it's iron 2 sulfate or ferrous sulfate. Lithium bromide. Magnesium chloride. Iron 3 chloride or ferric chloride. Number 7, when you get to it, the alarm goes off because it's a transition metal. When you look at this one, zinc just has 1 possible charge. So you don't need to say zinc 2. You can just say zinc. So it's just zinc phosphate. So if you ever come across any transition metals that have one number written above it, you don't need to use the Roman numerals, or the us and the ik. All right, so ammonium nitrate, aluminum hydroxide. Number 10 is one where knowing your polyatomic ions helps tremendously. This is acetate. It's got a charge of -1, +1. If you forgot that charge, the fact that it doesn't have a Roman numeral also tells you that it must be -1. So this is copper 1 acetate, or cuprous acetate. 11 is another one where if you don't know your polyatomic ions, it's going to be very difficult to name this. SO3 is sulfite. It's -2, so that must make lead +2. So this is lead 2 sulfite, or plumbous sulfite. Number 12, calcium oxalate. Number 13, iron 3 oxide, or ferric oxide. Number 14, we're just naming polyatomic ions, ammonium phosphate. Number 15, now you get into this transition metal mode where you think everything is a transition metal. Magnesium is an alkaline earth metal. It's a main group or representative element. So this is just magnesium nitrate. 16, copper is a transition metal. It has more than one charge, so you need to write a Roman numeral. So this is copper. Know those polyatomic ions. Copper 2 sulfate, cupric sulfate. $17 is baking soda. This is sodium bicarbonate. Yes, sodium bicarbonate. That's good old baking soda. Has so many uses. Okay, 18. Look on your periodic table. Nickel is, where are you? It's a transition. 28. It can be either 2 or 3. So you're going to have to use your Roman numerals. And you can do the cross and raise. You didn't even have to look at your periodic table, but just to double check. But it's not been simplified any. So this is nickel 3 bromide. And nickel, this one really doesn't have a common name, so nickel.
And then the one that we
Nicolic. No, we don't.
and zinc either use
Right. And zinc is because it only has one charge. So zinc wouldn't have the Roman numerals at all. Okay. Beryllium. You think it's a transition metal, but it's really an alkaline earth. So beryllium 2 L's, yeah. Beryllium, thank you. Beryllium, nitrate. Zinc is a transition metal, but it just has one charge. Just has that charge of 2 listed here. Zinc sulfate, sorry. And then the last one, cross and raise, gold 3 chloride or auric chloride. So I really want you to keep practicing this nomenclature. Work on experiment 8. It will help you tremendously. Memorize those polyatomic ions.
And the quiz is just on the